Hi, I'm Kathy Levinger. In this lesson we're going to look at applications of sine, cosine, and tangent. Let's start with this example. A 16-foot ladder leans against the wall of a house. The angle the ladder makes with the wall of the house is 15 degrees. How far is the base of the ladder from the house? Well, let's draw a picture and label the information that we know and see what we can do from there. We've got a house, something like this, and here's the ground. And leaning against the wall of the house is a ladder, and the ladder itself is 16 feet. Now, we need to assume that the house makes a 90-degree angle with the ground, and we're told that the angle the ladder makes with the wall of the house is 15 degrees. What we want to know is how far is the base of the ladder from the house, so let me label that x. What I see labeled in my triangle are an angle, the side opposite, and the hypotenuse. Remember that the sine of some angle is the ratio of the opposite side over the hypotenuse in that triangle. Filling in the information that I'm given in my problem, the sine of 15 degrees is equal to x, the length of the opposite side and what I'm looking for, divided by 16. To solve for x in this equation, I'm going to multiply by 16. 16 sine 15 degrees is x, and then pick up a calculator to figure out the number. What you should do when you begin working with trig ratios is check the mode of your calculator and make sure that it's set in degree mode before you make a calculation. I can see that my calculator is in degree mode, so I'm ready to calculate. I'm going to find 16 sine of 15, and that number's 4.14 and so forth. Let's round to one decimal place and say that the ladder is about 4.1 feet from the house. Let's try another. Andy sees a hot air balloon rising vertically in the distance. At the instant he notices the balloon, it's 200 feet above the ground, and Andy's line of sight to the balloon forms an angle of 65 degrees with the ground. How far from Andy along the ground did the balloon begin its ascent, assuming the entire ascent was vertical? Well, again, let's draw a picture to set up this problem. We have a hot air balloon. Here's my balloon with a basket. There's my hot air balloon. The hot air balloon, and here's the ground, is, at the time it's noticed, 200 feet above the ground. And here's Andy looking up at the hot air balloon, and we're told that his line of sight to the balloon forms a 65-degree angle with the ground. Now, we're not told how tall he is or whether to worry about his eye level, so we're going to make an assumption that he's eyeing the balloon from ground level unless told otherwise. Now, assuming that the balloon ascended vertically, its ascent direction would be perpendicular with the ground, and what we want to know is how far from Andy along the ground, or this amount, did the balloon begin its ascent. Well, in this particular triangle, we're given an angle, the side opposite and the side adjacent. That fits with our tangent ratio. Tangent of some angle is the ratio of the side opposite over the side adjacent. In this case, our angle is 65 degrees. The length of the opposite side is 200. The length of the adjacent side is what we want. There's a couple of steps involved in isolating y. We begin by multiplying each side of the equation by y to get y tan 65 equals 200, and then divide by tangent 65 degrees, and so y is going to equal 200 divided by tan 65 degrees. We want to calculate that with the use of a calculator, help of a calculator. 200 divided by tangent 65 degrees is 93.26. Rounding to one decimal place, that'd be about 93.3 feet. So let's say approximately 93.3 feet. Let's try another application. Elizabeth is out walking her dog. She walks from her house along the street north for half a mile, then turns the corner and heads due east. After walking for a few minutes in this direction, she remembers an important call she needs to make. She turns and heads home. If she could walk directly home by traveling due southwest, how far would she have to walk? Well, we better draw a picture to fit this situation. Let's put Elizabeth's home somewhere down here in the lower left corner, because the first thing she does is she walks north for half a mile. There's half a mile. Then she turns due east and walks for a bit. If she turns due east, there's a right angle formed between her north and her east line. She walks for a bit, and then she remembers her phone call, and she wants to travel due southwest, which is along this line, or she wants to determine if she could travel that way, and that line forms a 45-degree angle due southwest. How far would she have to walk to get home? So we're interested in finding this distance. Well, in our triangle, we have an angle, the side opposite, and the hypotenuse. That also fits with our sine ratio. The sine of an angle is the ratio of the opposite side to it over the hypotenuse. Our angle is 45 degrees. The length of the side opposite is half a mile. The hypotenuse I've labeled x, and it's what we're looking for. To isolate x, multiply by x, x sine 45 degrees equals a half. Divide by sine 45, so 1/2 divided by sine 45 degrees is what I need to calculate to figure out her distance if she were to go straight home, if it were possible. So on a calculator, now if you're going to use the fraction 1/2, not the decimal 0.5, be sure to put parentheses around that itself. Then divide by sine 45, and that number's 0.707, let's say 0.71 approximately. And our units are miles in this particular problem. She'd have to go 0.71 miles if she were to go directly home. Well, let's look at one more example. Ken is sitting at his desk editing videos. He searches on his desk for his pencil and then notices it lying on the floor 12 feet away from his feet. If his line of sight to the pencil forms an angle of depression of 18.5 degrees, how high above the ground are his eyes while he sits? Well, let's draw a picture. Suppose that Ken is sitting here and his pencil is 12 feet away, so these are his feet at this point. His pencil is 12 feet away lying on the ground. Now there's this information about how his line of sight forms an angle of depression of 18.5 degrees. Suppose that his eyes are at this level. An angle of depression is measured down from the horizontal. So he's looking at the pencil. This angle is 18.5 degrees. The question is, how high above the ground are his eyes? Let's call that side x. Well, this 18.5 is not in our triangle. There's a couple of ways you can work with it. You can subtract it from 90 to get this angle in the triangle, or realize that it is exactly the same as this lower angle in the triangle. Once that's labeled, I have an angle, an opposite, and adjacent side labeled in my triangle, which means I want to use a tangent ratio, which is the ratio of the opposite over the adjacent side in the triangle. Filling in the numbers that I know, Tangent of 18.5 equals x over 12. To solve for x, I'm going to multiply by 12, and I should call that degrees. And now I'm going to use my calculator and find 12 tangent 18.5, and that number's approximately 4. And so we could say that Ken's eyes are approximately 4 feet above the ground while he sits. In this section, we've looked at applications of the sine, cosine, and tangent ratios. Be sure to work lots of exercises from your textbook for practice.